Hey geometry students, Mrs. O'Donnell here. This is our lesson on volume of cones. Our goals for today are to find the volumes of cones. Don't forget to come to office hours if you have questions or you feel like you're struggling and you want a little extra help. Okay, so what is a cone? Okay, just like an ice cream cone or a cone you see in the road, like a traffic cone. A cone is a solid with a circular base, a vertex, and a curved surface. Now, what you may not know is that cones are actually this entire figure right here, which is called a double-naped cone, right? So typically when you think of a cone, you're really only thinking about half of that figure. A cone is actually both figures, both sides. Okay, so it's as if you have that pencil and you've sort of twirled it around from the center. That's what forms that cone. Okay, cones have a height, so you have the height of the cone, they have a circular base, and they also have a slant height for your cone. Some cones may not necessarily meet the ground at a 90 or meet their base at a 90-degree angle. You could have an oblique cone, which is a cone that's sort of been kicked over, right? You have your base and then your cone itself is very slanted. I like to think of waffle cones. I think waffle cones are a really good example of oblique cones in real life. All right, so we can find the formula for volume of a cone based on the formula for volume of a cylinder with the same base and height. Okay, so I'm going to show you this video again. There's a little bit of repeat and overlap from what we learned about yesterday with finding the volume of a pyramid. So I want you to notice any similarities and differences from how we derived the formula for volume of a pyramid. Same height and base. Predict how many cones do you think it will take to fill up that cylinder? All right, voila. Okay, so hopefully you noticed, hey, there were three of the same pyramids that filled up the prism with the same height and base. Same thing with our cone. 3 cones filled up the cylinder with the same height and base. Okay, so here's our formula, right? So just like we did for our volume of a pyramid, we did 1/3 times the area of the base times the height of the prism, right? So in this case, to find the volume of a cylinder, right, we have to do pi r squared, that's the area of that circular base, times the height of the prism. Well, now we're going to do that same formula, but then we're going to multiply it by 1/3 as well. All right, so let's try it, right? So find the volume of the given cones. What strategies did you use, right? So if we check out this one on the left, and if you want, you could go ahead and pause the video if you think you've got a handle on this, give this a try, and then unpause to check your answers, okay? So first thing we're going to do, we've got our 1/3. We're going to do the area of our base. So we know to find the area of that circle, we're going to do pi r squared. So pi times our radius, which is 9 squared. And then we're going to multiply by the height of the cone. Okay, so I know it's a little, this cone is kind of upside down like an ice cream cone, but the height is still from the circular base, making a 90-degree angle with that circular base to that vertex of your cone. Okay, so in this case, it's going to be 12 centimeters. Okay, and you could grab your calculator, right? 9 squared we know is 81, times 12 gives us 972. You could divide that by 3, gives you 324, times pi gives you 1017. I'll round to the 10th place, 0.9. And we want to make sure we use the correct label. We're finding volume. Volume is 3-dimensional, so that means that we're going to have centimeters cubed. Okay, that would be our volume. All right, let's go ahead and check out the one on the right. Okay, so if we check out this cone on the right, we're going to do volume equals 1/3 times the area of our base. Now we have to be careful because what they're showing us here is actually our diameter of the base. And to find our area of our base, we need to use radius. So we're going to take that 11, we're going to cut it in half to get 5.5 feet, right? That would be the radius. So we're going to do pi times 5.5 squared, and then multiply that by the height of our cone, which is 7.2. I'm going to grab my calculator to get a little extra help. 5.5 squared is 30.25 times 7.2 is 217.8 divided by 3, 72.6 times pi, okay, which gives me a total volume of 228.1 feet cubed. All right, now you may notice I really multiplied that in a random order. Remember that commutative property of multiplication allows us to multiply in any order we want as long as that's the only operation that's being done there. Okay? And that's really all I've got for you guys today for volume of cones. It's pretty straightforward. Nice quick video for you. Make sure that you log in, do your delta math that corresponds to finding the volume of cones, do your Google form, this daily Google form, and then come to office hours if you have any questions. All right, thanks so much, guys.